Hello everyone, I am Prabha, working as an assistant professor in Department of Chemistry at Katpam Academy of Higher Education. In last class we seen about genesis of periodic table. Today we are continuing that what is the Dimitri Mendeleev work in that genesis of periodic table. Shall we go to the topic? The topic name is genesis of periodic table. In that, today we seen about work of Dimitri Mendeleev. Mendeleev period is 1894 to 1907. Okay, sorry, 1884. Okay, so in this period, he working as an arranging the elements in periodic order. Okay, what is his principle is the properties of elements or their periodic function of their atomic weights. Okay, the properties of elements or periodic function of their atomic weight. In before all the scientists taking as an atomic mass, but here Dimitri Mendeleev taking as an atomic weight as an elements function. Okay, so what we gonna to done means he arranged the elements in atomic weight order. Okay, so in atomic weight order he noticed that what is the significance of periodicity. So in arranging the chemical elements, this periodicity is most important one, and while arranging the tables he noticed that atomic weight is not strictly followed to arrange the elements. So he consider as another physical and chemical properties of the element to arranging them. Okay, so what we gonna to done means he arranging the elements in similar properties. Arrange the elements according to similar properties. Okay, so here this is the table he making that. What he gonna to do means he arrange the elements in row and column wise. Okay, see he created a one table and arranging the elements first atomic weight wise, but it is not suitable for many elements. So he go to the topics another properties. Okay, so another properties what he take means similar properties. In similar properties these elements are arranged by arranged in the order which have similar properties like helium, neon, argon, krypton, xenon are same physical and chemical properties. So they are arranged in one group. Okay, and likewise here the fluorine, chlorine, bromine, iodine are same properties, so they are arranged in one another group. Okay, here what is the notable point is the iodine and tellurium. Iodine have 126 atomic weight and tellurium is 127.6. This is a lower atomic weight than tellurium, but he arranged the iodine in group 7 because of its similar properties of iodine with chlorine and fluorine and bromine. So that's why he take a main property which have similar and physical and chemical properties. He not consider the atomic weight. Okay, so what is the another point means he identified some of the elements. Okay, here in the period of Mendeleev arrangement, this gallium and germanium is not determined. That means not identified. So what he done means he left the gaps in his table likewise this. Okay, here nitrogen, phosphorus, here he put a gap, and oxygen, sulfur, and down that he put a gap. So what he make is in his table he making as some gaps for filling the elements which is identified in future. Okay, so this gallium and germanium it didn't identified in the period of his arrangement. So what he given name for that gallium means eco aluminum, and germanium he given name eco silicon, because these elements are have a same physical and chemical properties like aluminum and silicon. So he given name eco aluminum and eco silicon. He not only predicted the gallium and germanium, he also predicted the some of the physical and chemical properties of gallium and germanium which may not be before the identification of gallium and germanium. He not mentioned that two only, he also identified the physical and chemical properties of many other elements. And in the last row he arranged the metal atoms which have similar properties like iron, cobalt and nickel, and here ruthenium, rhodium and palladium, in here osmium, iridium and platinum. These elements or these metals are having same similar properties, physical and chemical properties. So this is the Dimitri Mendeleev's periodic table to arrange the elements in their physical and chemical properties wise. And we continue the another subtopic, that is modern periodic law. Modern periodic law and present form of periodic table. Present form of periodic table. Now this present form was developed by from the observation of English chemist Henry Moseley in the year 1930. What he observed means, here he characterized the physical and chemical properties of the elements by X-ray studies. So from the X-ray analysis he draw the plot against X-ray characteristics and atomic number. He against the plot these two functions, he get a straight line. Okay, but he didn't get a straight line for X-ray characteristics along with atomic weight. So what according to this X-ray studies confirmation, we arrange the periodic table, Mendeleev's periodic table. He arranged the Mendeleev periodic table, or we modified the Mendeleev periodic table according to atomic weight, according to atomic number. So this observation, the Mendeleev arrange the elements in vertical row and horizontal columns. Here we also in modern periodic table we have a horizontal groups and vertical periods. Okay, so here the horizontal rows are known as group and vertical lines are known as period. Okay, so this columns is considered as a periods and this row is considered as a group. Okay, this row wise it is considered as a group and this column is considered as a period. Okay, in this modern periodic table it is easily clarify the electronic configuration and valence of electrons. Valence of electrons. Okay. So period to period this periodic table is modified various forms. Okay. So some of the forms are stressfully explain the chemical reactions and valence, and other all form of periodic table explains or stress only electronic configuration of the elements. Okay. So from this the new periodic table, the properties of elements, are they their function of atomic number. This is the basic principle. Okay. So according to this principle, here we are rearrange the Mendeleev periodic table. In this Mendeleev periodic table, that group is divided into 18 numbers, and the period is segregated as a 7. Okay. So in this first period, only two elements are there. One is hydrogen and another one is helium. Here the most maximum quantum number is 2. And here another one, lithium, beryllium starts to, and neon. Here the maximum quantum number is 8, and in third row maximum quantum number is 8, and in fourth and fifth row the maximum quantum number is 18, and sixth and seventh the maximum quantum number is 32 and 32. Okay. Here what we do means, in 18th period it is considered as a 0th period. Okay. Here the noble gases are arranged in 0th group, likewise Mendeleev periodic table, and the groups are named in 1A to 7A and group 8. This vertical columns 8, 9, 10 consider as a group 8, and again the group is continue as a 1B to 7B, and last one group column consider as a 0th group. Okay. So this modern periodic table was clearly explained the electronic configuration of the elements, and also clearly shown that what is the importance of quantum number to arrange the elements periodically. Okay. So these numbers are a primary or maximum quantum numbers of that elements. Here first row two elements are there, one is hydrogen and another one is helium, and second and third row totally we have 8 elements. Okay. That two are in S block elements and 6 from an P block elements, and going to 4 and 5th period we have totally 18 elements, 2 from S block elements and 10 from D block elements and 6 from P block elements. And here from 6th and 7th we have a one exception. What is that means? Here this lanthanide and actinides. Totally the lanthanides are 14 elements and actinide have another 14 elements. Here these 14 elements are arranged in a one box. Why they are arranged like this means, these 14 elements have a similar physical and chemical properties, and again in below this actinide 14 elements have a same physical and chemical properties, but their atomic numbers are different. Okay. So that's why these 14 elements are combined in a one box. Okay. So counting that 14 elements, and here actinide 14 elements, this 6th and 7th period totally have 32 elements. So from the quantum numbers we have 32 and 32. This also obey the principal quantum numbers. Okay, and finally, the modern periodic table created like this, and now totally here we have 118 elements from 1 to 118 elements, total elements are in our periodic table. Here that up to 94 we have naturally occurring elements, and after that we this inorganic field of chemistry should develop the similar elements which is artificially synthesized. Okay, artificially synthesized also kept in this periodic table. Okay, and up to 94 there are naturally occurring elements. Finally, we seen about what is the significance of periodic law to arrange the elements in the new form of periodic table. So in the new form of periodic table, totally 2 points are main. One is electronic configuration and another one is quantum number of the elements. This 2 is more significant than atomic weight and atomic mass. So, okay, so finally what is the conclusion means we today seen about Dimitri Mendeleev work in elaborated form and his worked table, and in 1907 he published his work, and then we seen another subtopics, modern periodic law and present form of periodic table. Okay, in the next class we have to see about what is the types of elements present in the periodic table according to electronic configuration. Okay, thank you.